So right now we're hard coding 4, right? We're multiplying the block or the buffer, the output. We're multiplying it by 4. Wouldn't it be cool if we had a slider or something so that we didn't have to hard code it in? Now, what we could do is go into the editor, make a slider, go through all that nonsense, place it on the screen. You know, it would take like 10-15 minutes to do that. Something we could use is alternatively is an audio processor value tree state. Okay, so this kind of solves 2 problems for us. This is something we need anyway. This is what sets up automatable parameters in the DAW. So if you don't use this tree state thing, you won't have any parameters in the DAW. But making this tree state thing gives you those parameters, but you can also use it to create a very quick generic GUI that you don't have to actually code any UI or visuals. So let's set up the tree state, which is something we need anyway. We need a value tree object, so an actual instance of it. And for right now, I'm just going to make it public. Yeah, so it's a audio processor value tree state, and it's called tree state. Now, this doesn't have a default constructor, which means that if we just try to build right now, it'll give us an error saying that, will the error say, will it just say no default constructor? Right. So constructor for tree state must be initialized because it doesn't have a default one. Now, a default constructor would be something like, if I go to DSP, chorus right here. So this is the constructor. You can see how there's no arguments or anything in it, which means that it's a default constructor. But some other things like the oversampler doesn't have a default constructor. It has a constructor that you have to pass some information in. And that's the same thing as the tree state. So what we could do, we can actually do this 2 different ways. It doesn't really matter. We can go into the constructor initializer list right here, and we could say tree state. And yes. Okay, processor to connect to, we would just say this. Undo manager, we're not going to use an undo manager, so we're going to use this cool C++ thing called null pointer. We need to give it some kind of identifier. So I'm going to call this parameters, which is what I always call it. And parameter layout, that's another thing we need. So parameter layout is this right here. Let's go put that. This one can be private, it doesn't matter. So this is a parameter layout. It's called, you know, create parameter layout. But what do we need to pass in? Oh yeah, just create parameter layout. Oh, and I forgot this needs to be dereferenced. Yeah, so we pass this create parameter layout into there. And now the tree state is constructed, but now that we have this create parameter layout, we're going to have another issue because it's not implemented, I think. Right. So undefined. Oh, you get this weird linker error. Yeah, so that's not super helpful all the time. Create parameter layout. That just means that we haven't implemented it. So we need to actually implement it. And let me go ahead and pull it from here. And it doesn't matter where you put it, but I like putting it at the top. I don't even really know why, but yeah. So the one thing about copying and pasting from other projects is the other project's class name is going to be there. So you need to copy and paste the current project into it. And I'm going to delete all of this except for one. This is the parameter layout, and this is kind of the container for our parameters, our automatable parameters. So we make a vector, which is a data structure. It's kind of like a array in other languages, but a vector, you know, you can change the size dynamically, and you know, it's cool. So yeah, we make a vector of type ranged audio parameters, which is just the audio parameters. We're calling it params. And every time we make a new parameter, we have to push it into this vector, and that's what this is right here. This is what this is right here. Params.pushback, and then we add the parameter in there. And then this method just returns those parameters. And then this is how we actually create a new parameter. We can say auto, which will make it the type that it needs to be. We'll call it whatever we want. What are we doing right now? We're doing volume. So let's just say gain. I'm going to call it gain. So now I need to take it and put it into this right here, because this is where we're pushing it into this params vector. So we need to make sure that the names are the same. So we are using make unique pointer, which is a smart pointer in C++. Basically, what this type of smart pointer does, I believe that whenever it goes out of scope of whatever it's being used for, it gets deleted without you having to do it, which is really cool, because the other way to do this would be to make a raw pointer, but then you'd have to manage the memory and you'd have to remember where it needs to be alive and all that nonsense. So, you know, smart pointers are the way to go. There's really not a lot of reasons to use raw pointers with all these new C++ features. So we're making basically a audio parameter, and there's a couple of different things you could do. There's audio parameter float, int, bool, and choice. So audio parameter, actually, let me not skip ahead. I was going to explain what each one looks like, but let's do this first. So each audio parameter, you have to give it an ID and a name. The ID is what the JUCE project will use to reference to it. So I'll just call it gain. And the name is what you'll see come up in the DAW as the parameter's name in the automation data. So I usually you just make it the same word, but with a capital letter. That's a pretty good way to do it. And then this is the range. So the starting value, the ending value, and or not starting, but the lowest value, the highest value, and this is the starting value, wherever you want it to start. So this is gain. So let's make it -24 to 24. And then let's make it start at 0 so that it's always in the middle. And that is it. We have a parameter that we can call other places in the plugin with this gain word right here, which is cool, which means that in here we could do this. Instead of saying 4, we're going to multiply, instead of by 4, we're going to multiply by what is in the tree state. So we can say tree state dot get raw parameter value, and we pass it in what we want, which is gain. Cool. And that would work. So now whatever the value is, it's being multiplied by that. But this is pretty ugly, right? If you need to write it in other places, this isn't really helpful. So we can just make a variable up here. Like, let's just say float gain, and then we can set it equal to this. Or let's call it raw. Let's call it dB gain. Because this is -24 to 24, which is dB, right? Which brings me to my next point. We could do this. We could take this dB gain and we can multiply it by our signal. But this is -24 to 24, right? We need to, that's not what it actually wants. We need to change it to a logarithmic gain value. So what we're going to need to do is multiply it by something that's between 0 and greater than 1, right? So if you multiply the signal by something greater than 1, the signal goes up. If you multiply the signal by something between 1 and 0, signal goes down. And if you multiply it by something negative, you're not going to have a good time. So dB has negative values, so we need to change this into a gain. So we can do another variable right here. We can call it raw gain, which is the actual kind of 0 to whatever log value. We can set that equal to this really handy JUCE method called dB to gain. Now, if we didn't have a JUCE method, we could use a PAL function. And the conversion from dB to gain is 10 raised to your gain divided by 20, and that's how you would get to gain. So that's kind of that's not the code way to do it. The code way to do it would be to use a PAL function, a C++ PAL function. So what this is doing is it's multiplying the first argument, not multiplying, sorry. So it's taking the first argument and raising it to the second argument. So right here we would put dB gain divided by 20, and right here raw gain, and that would work. Cool. So this is the conversion. Now this is kind of annoying to have to write all the time, and it's also not super clear what's going on. So there's actually a better way. JUCE implemented a version of this. I'm not sure what it does under the hood. There might be some extra stuff, but there is a decibel to gain conversion in JUCE, and it's inside of the decibels class. We got decibels, and then it's got dB to, or decibels to gain, and then you type in your dB gain, and it will convert it to raw gain, and that will work. So that's all set up. That works fine. But we still don't have a slider or anything to actually interact with this. And like I said, one way to do this would be to actually go to the editor, make a slider connected to the tree state with a attachment and all kind of nonsense. But we're not going to worry about that in this video because we're going to just kind of rely on audio. So there's this really awesome thing that I had no idea existed until the audio programmer made a quick tutorial about it. Right here in this method, this is how, so sorry, let me do this. Let me build the plugin. Now this GUI, the window that you see for your plugin, is called the editor. And this pops up and exists because of this function saying return new project name audio processor editor. Now what you could do is, instead of returning that, you could return what's called a generic one, generic audio processor editor, and pass it the same this argument. And what this will do is it'll create a generic editor that is based on what you have in your parameter layout. So watch this. We have one float parameter called gain, and when I build this, look at that, a slider called gain comes up and you can interact with it. So this is a basic slider that you can use to interact with it. You can't change the way this looks or anything, and as you add other things, it'll just kind of plop it down below, and the plugin window will get bigger and bigger as you add more things. But it's a million times faster than going into the editor and creating a UI, especially when you're just prototyping DSP or prototyping a project for somebody. It saves you just a massive amount of time. And what we could see is I'll do not standalone so that it actually builds it in the plugin version, and we'll open it in Logic and we'll check it out. Okay. Okay, so now we've got our window, the same generic parameter window. So let's check it out. Oh, look at that. I mean, look how fast that was. All I did was, so making these parameters takes time, but this is something you have to do anyway to have automatable parameters. So by simply changing this to return a new generic audio processor editor, now we have a UI that's going to build itself every time we make a new parameter. And check this out. We can automate this since we have, I'll show you, since we have the tree state and the parameters. Look at that stream, and look, we have our gain parameter. And check this out. Look at that. Automation works. It works perfectly. I mean, it was super quick. I mean, look how easy that was. Like if I wanted to go in and create a simple UI, like if I even just wanted to remake this UI to make it look the exact same, even though this is kind of the default setup of a slider, it would still take maybe like 10 minutes or something to make this. And then if you're just starting out, it might take even longer because you might not be aware of some of the kind of quirks of UI and setting up a JUCE UI. So there might be some things that I think are quick to set up that actually aren't for a new person. So it might actually take you like half an hour or something to just make this. So making this or returning this generic audio processor editor is just amazing. Like it's just awesome. So yeah, I mean, that's it. So let's close that. The only thing that we haven't done is if I save, it's not going to save the, like, let's say I move this and I hit save. It's not going to, when I reopen the project, it's not going to save it because we haven't done that yet, but that's not super important yet. Let me show you what some other things look like. So let's make another one. Let's make one called phase. Oh, and by the way, the reason I'm putting P in front of these is just because it's called, to me, they're parameters. So I'm just saying, you know, P for parameter. So equal std make unique. Oh, one thing I want to mention, something I was unclear of when I was starting is differentiating between what's a JUCE thing and what's a C++ thing. So whenever you see std::, that's the C++ standard template library. So that's going to be a C++ thing. And then obviously if it's prefixed with this JUCE namespace, it's going to be a JUCE thing. So C++ doesn't have audio parameter float, but it has make unique pointer. So so make unique, the class that we are making the pointer of, which is an audio parameter float. And then, oh, sorry. No, this is phase. So the whole point is I wanted to make a bool. So we can do bool. And we pass it the same thing. Let's see. It'll be phase. So let's say phase. Phase. And then for bool, the other argument is the default state. So I'll say false. And then we need to push it back into this params vector, this little data structure. Cool. So that's in there. Let me clean this up a bit. So I just added something called phase in there. So we should be able to build and see what it does. Look at that. A little checkbox. So that's what the bool does. Whenever you make an audio parameter bool, it'll give you this toggle box, which is something you could set up in the editor. But like I said, this is a million times faster. Okay, that's it for this video. Thanks for watching. Check out my streams over at Twitch at twitch.tv/Dr_Bruisin, where I live stream JUCE and audio development tutorials on Mondays, Wednesdays, and Fridays at 5:30 Central Standard Time. I'd love for you to drop into the chat, ask me questions live, and interact with me on stream. And don't forget the stream is also on my YouTube at Dr. Bruisin. You can also download the Viator DSP library that I'm currently working on to make JUCE development even easier and faster with awesome looking user interface objects and DSP classes. There's also a documentation page for it, which is pretty cool, and you can find both of them on my GitHub. All of my current plugin releases are on my Patreon at Viator DSP and can be downloaded for free, but consider becoming a patron to continue to support me making free audio plugins. I'd also like to share two awesome Discord communities, Viator DSP and the Audio Visual community. Both are dedicated to all things audio, so music production, recording, mixing, mastering, coding, JUCE, pretty much anything. We would love to build an active community of like-minded folks who can learn from, collaborate with, and just hang out with and do whatever. The link to all of these resources are down in the video description, and I can't wait to see you there. All right, see you next time.